I'm recording now. Okay, entonces, scientific calculator is extremely important in this chapter. Everyone need to pay to buy one. Okay, buy one calculator, guys. Let me see here. Okay, the first thing I want to recall something about the function that we studied in the chapter 2. For example, we have, you remember that we have, for example, one-to-one function. One-to-one function. Okay, what is that? This is when the one, suppose again the same schematic way, domain and range. Domain and range. And several elements of value inside the domain, you assign only one, x2, x3, only one value of the y in the range. Okay, when the situation happens, this function is called one-to-one. We have another possibility. Domain and range. Another possibility in which, for example, you have several values x1, x2, x3, x3, and you, for example, assign this to the same value, okay, y1, and maybe this and y2. This is one-to-one, this is many-to-one. Many-to-one. But this is also function. Okay, this is a function. And this is a function also. But one-to-one is super special. Super special. For the reason that you can see in several minutes. Entonces it's important now determine si one function is one-to-one or no. The fantastic way to determine si one function is one-to-one or no is using one new test que is called horizontal line test. Horizontal line test. I suppose that you remember very well vertical line test. Vertical line test. Vertical line test, I explained in the chapter 2. Y este test que allow me determine si the graph is a function or no. So for example, we have this situation, one graph like that, and one graph like that. So when you apply the vertical, crossing one point, and this case, no, crossing 2 points, this is no function. And this, yes, it's a function, it is a function. Okay, I suppose you remember very well this. This is the test that allow me to determine when you have the graph, of course. The function. And what is the idea of the horizontal? Get the new one that we study now. Well, the new one, the horizontal, allow me determine si the function que actually is yes, that pass this test, is one-to-one or no, and one-to-one is a special function. Suppose, to understand this, suppose that we have the classical parabola. This is x squared, basic, and we are the cubic function. The cubic function, you know, is like that. So in this case, to investigate if it's one-to-one function or no, you apply one thing, it's called horizontal line test. And this is similar idea, is you apply hypothetical in any position horizontal line. Si crosses one point, yes, a one-to-one. And in this case, no, because crossing 2 points or 3 points, no one-to-one. Of course, it's a function, but no special, no one-to-one. So what is the reason it's important to be one-to-one? Ah, because si you discover que the function es one-to-one, the direction of the function normally is in this direction. This is f. However, you can invert the direction of this arrow, and you need to find the inverse function, que is the second piece of the problem. Bam, 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 inverse function. Okay, entonces the notation que we are using in function notation, are you familiar, is y equal f of x is the original function. Original function. In the opposite direction is the inverse function. And the notation that it's using is, you know, it's a little bit weird. It's f negative 1. So it's y equal f negative 1. And this negative 1 is no exponent. No. It's the super symbolic way to indicate inverse. So this is synonymous to say inverse. When you see a function and you see a negative 1, this negative 1 is no exponent. Si es exponent, you put a parenthesis. No. It's f without parenthesis, negative 1. This is inverse. Okay, professor, I understand this. But what means inverse function? Well, are you familiar with inverse function? Because, for example, addition and subtraction is two inverse function. Because suppose you pick 1 point, one value, 10, and you addition something, suppose 5, 15. And if 15, you subtracting, get the inverse, I suppose hypothetical, no? The same number, 5, 10. And we come back at the beginning. Look, es la que on dos each other. A similar situation happens when the multiplication and division. Let's do a multiplication. Suppose 10 times 5 is 50. And 50 divided by 5 is 10. We come back at the same value because we are doing consecutive, sequentially, two inverse operations, un dos de affect each other. Another example I like to present is the classical square and square root. Suppose we have 5, and when you square, it's 25, no? And when you find the square root, get the inverse operation for the square is 5. And we come back at the beginning. Do you understand the idea behind inverse function? So I put a classical example. Addition, subtraction is elementary. Everyone understands. Multiplication and division, everyone understands. Square and square root, everyone understands. But we study in general. For any function that's given, you need to determine the inverse and their property. Okay? Okay, one more thing. Bueno, professor, what is the connection between one-to-one? See, look, see the function is not one-to-one. It's obvious that the function is not invertible. Why not? Because this function gets many to 1. This is the arrow to represent the function f, no? And the inverse function, I suppose, is in this direction. But in this direction, this function is hypothetically, I suppose the inverse function is one to many. Because I interchange x and y, one to many. So as you swap this letter, the one to many no function. Entonces this do not exist. Okay, entonces what is a super fantastic conclusion? The inverse function exists only si the function is one-to-one. Okay? Si the function is not one-to-one, do not exist. So, okay, I understand so far. However, I see some contradiction. Because in the example you illustrate here, you put a square and a square root However, in one moment of the lecture, you say that function que es square is no one-to-one. Entonces, si es no one-to-one, professor, is no invertible. Entonces, what is the reason que the square, the inversive function is a square root? Okay, I understand this concern. However, I solving that problem because suppose that function now. Look. Suppose that function now. This is xy. The equation is the same, but intentionally I put not the entire parabola, one half of the parabola. The part que you have, or the positive part or the negative part. Entonces, my question is, this new function, que by the way, is a function f of x, like so, expressed like a piecewise function, is x squared if x is positive or 0, and 0 if x is negative. Because actually, that part is 0. Okay, this new red function passed the horizontal line test or failed the horizontal line test? Passed the horizontal line test or failed the horizontal line test? Pass or fail? Answer me. Pass, because when you are doing the horizontal line, closing one point. Okay, entonces I can, modification a little bit the domain of the function. So you suppose the function x squared, like that. And the supposition of the domain is all real number. This function is not one-to-one, therefore is not invertible. However, so you suppose this is the same expression, but you make a restriction in the domain, que is bracket 0, infinity, or it's the only positive value. This is one-to-one, therefore it's invertible. Invertible. Everyone follow me or confusing? Come on, opinion. Opinion. Entonces, well, wait. Confusing? Okay. Holmes, what part? What part is confusing? I recommend that you see example. When you see example, you understand more clear everything. Okay. Entonces, okay. Entonces, what is the key idea for finding the inversive function? Well, first of all, identification if the function is one-to-one or no. Si it's no one-to-one, si the answer is no, and the story is no invertible and we have no inverse. Well, suppose que yes, it's invertible. Okay, good. So now what should I do? Well, okay, you interchange x and y. This is the key idea. You interchange. You have x value and y value, and you interchange x and y. In other words, the hypothetical domain you suppose at the beginning, and the original f function, and the range you suppose. Now you interchange. Now my range is domain and the inversive function, and the domain is my range and the inversive function. So you interchange x and y. This is the most important thing. Let's see example, Mr. Holmes. I promise you understand very well now. Okay? Let's do it. Example 1. Example 1. I have here. Example 1. Okay, this is too long. This example is long because we have 5 steps. We determine the inverse, determine domain, determine the range, determine the checking CS inverse or no. And finally, we are doing the graph. So example 1, one function is given, is f of x equal x cubic plus 3. Okay. So step 1 is determine if my function is given is one-to-one or not. And the professor explained that the only tool that we have in my hand to verification that is the one, the horizontal line test. The horizontal line test. Okay. Entonces I need to know the graph of this. Well, I know by memory that the graph of the given function look like that. I suppose you remember the collection of the most important, no? Function called algebra, one paper that I sent to you, no? Square, cubic, reciprocal, absolute value, square root, cubic root, etc. But this function is given a family course of this, because the only thing that we are doing is +3, and +3 is vertical shift over 3 units, right? Also, it's the same shape. It's doing here, xy. It's the same shape, but this point is 0,0 origin. Now it's not 0,0, it's 1, 2, 3. It's 0,3. And the graph is similar to this. It's the same shape, but you move over 3 units, point by point. Entonces my question is, pass the horizontal line test or fail the horizontal line test? Pass or fail? When you have this information in my hand. Pass, pass, obviously pass. But when you are doing horizontal line, closing one. Okay, therefore, the conclusion in the step 1 is 1-to-1. It is. It is 1-to-1. I know, theoretical, that any 1-to-1 is invertible. In other words, the inverse function. This is the symbolic way to indicate inverse function. Exists. Okay, this is the step 1. Verification. The is 1-to-1 or no. See, the answer is no. We finish this example because we have no inverse function. Step 2 is the most important step. Is find the inverse function equation. Inverse function equation. Okay, well, when there's addition, subtraction is easy. When there's multiplication and division is easy. But in this case, no, because this is a combination different. Okay, the original function is x cubed plus 3. So what is the inverse function of this? This is my challenge now. Look, I need to find the inverse function. Okay, remember the symbolic way is using the -1 to look like exponent, but actually it's not exponent. So we need to find that. And the procedure is always the same. Pay attention, it's important. I copy my original. But the only thing I do was replace f of x for y, because you know it's the same. So y and f of x is the same, but this is function notation gets useful for professors say to understand much better the transformation, something, but no, in this case, no transformation. It's y equal x cubed plus 3. And the only thing I did from this to this is replace f of x for y. Now, this is a crucial moment. Interchange x and y. Boom, boom. X here, y here. Do you understand what you're doing? Do you understand what you're doing? Do you understand what you're doing in this step from this to this? Answer me. Okay, good. Dylan said yes. Okay, so actually, the expression I have here Inverse it. Ok, pero profesor. Ok. To invert. Yeah. To invert. The action is to invert. To find the inverse. To find the inverse. To find the inverse is equivalent to say the verb to invert. Okay. Entonces, you say, Professor, this is the inverse. No. Well, yes. But what's the problem? The problem is que se expresa en implicit. Implicit form. And remember, implicit is the form que es no clear. Implicit is synonymous to say no clear. I need the explicit form, always. Explicit is super clear. Explicit is synonymous to say clear. And how you put clear? Well, clear is when you isolate the y. Entonces I move 3 subtraction. Entonces en order to isolate the y, so solve for y is the action. Explicit is when the y is isolated. You apply cubic root both sides, similar to what we are doing in radical equation. And we have cubic root x minus 3 equal y. Wow. And this new y represent the inverse function. The super fantastic conclusion is that the inverse function here that I am looking for, try to find, is cubic root x minus 3. Boom. Of course, we don't finish. We have more steps. We have 5 steps. And make sense or no? Yes. Emily said yes. Because remember, it's like inverse is opposite. Entonces, in the original function, the thing we are doing is addition 3. Oh, no. First of all, raise to the cubic power and plus 3. And we are doing in complete inverse operation, subtracting 3 and find the cubic root. So now, to checking, see everything is okay, because the intuition is okay. I understand, makes sense. Look, this is cubic, sorry. This is cubic here, cubic root, and the index of this root, cubic root. To do this more clear, at least for me, I propose you step 3. Step 3 is I want put together this expression and this expression. How? Together. Okay, is using composition. Okay, suppose I make a composition F inverse. Boom. Or why not F inverse composition F. Remember composition. Composition is one function inside another function. But I have no idea. I at the beginning of the lecture, I tried to make composition, no? Addition, subtraction. So you add addition 10 and subtracting 10. We are doing nothing. No? So we come back again to the original problem. Yes or no? So you multiplication by 3 and divide by 3. We are doing nothing. So I suppose that if you are doing this operation together with this operation, we are doing nothing. And what means nothing? Nothing is the original value. Okay, called x. So you get this answer, you are right. Let's do it. Suppose in that order. And that order means that the inverse is the first function. Go inside f, get the second function. In other words, this expression replace here. Okay, entonces es cubic root of x minus 3 raised to the cubic power. This cubic power is this cubic power. Plus 3 should be, I don't know. Es obvio cubic root and cubic power together endoss each other. Because we have x minus 3 plus 3. Wow, look at that. Cancel out. Chun chun. The answer is x, exactly the value expected. Because this function endoss each other. In the other direction, well, in the other direction, I have no idea, professor, because when you explain composition, you say the F composition G never is equal G composition F. So there are no possibility to get the same answer if you commute this function. The order is important. You say, professor, that the order is important, the order is important, the order is important. And this case is important. No, in this case, no, because it's a special case. Look. Suppose now we are doing completely different. You take this SF and substitution here. And we have cubic root, not x anymore. No. It's x cubic plus 3. Guess this expression. And minus 3 inside the brackets. Oh, look at that. This is canceled. And we have cubic root of the x cubed. Okay, again is x. Done. We prove mathematical double checking. Okay, this function and this function is inversive for sure, 100%. Okay, that's it, no? No. Okay, what is the fourth step? Well, the fourth step is determine the domain and range of both functions. Okay, step number 4 is determine domain of the original F, the range of the original, why not? The domain of the inverse, and the range of the inverse. Okay, let's move on. I want to copy here the original. The original I just given in my problem was y equal x cubic plus 3. See, I asked you, what's the domain of that function? Bueno, professor, you explain the domain, the supposition is all real number except the restriction. And we have restriction only when you have fraction or square root. Cubic root, no. But square root, yes. Well, does this function have no division, have no square root, therefore the domain is only. And by the way, this domain is equal the range of the inverse. Why, professor? Because remember, the only thing that we are doing to find the inverse was interchange x and y. Okay, so in other words, the domain of the original, I guess x, now is transferred 100% to the y and the inverse. That this is equal to this. Okay, in general, one fantastic theorem. Domain, in general, domain of F. Domain of F. I call F the original, no? Is equal range of the inverse. And likewise, range of the F is equal domain of the inverse. This is in general. In particular, for this example, well, this is equal to this. It's exactly this statement, this one, this statement. And what about the second? Well, the second, okay. Always, you know, it's very, very complicated to find the range of the function. It's more complicated. The domain, no. The domain is relatively easy. It's complicated, but it's relatively easy. The same because the function is 1 to 1. Yes, yes. And you interchange. Remember, what was the beginning of this story? You have to say, I declare this domain of F, I declare here range of F, and that direction. But so you change the direction, this is domain, this is the original function, this is the inverser. Now, this is the domain of the inverser, and this is the range of the inverser. Okay, and so this guy, and this guy is equal to this guy, and this guy is equal to this guy. It's exactly the same in too many words. Blah, 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 blah. I write it. But what about the range? What about the range? Well, the range is always complicated, but the domain is relatively easy. So I propose you do it in different order. So I try to find the domain of the inverse. It's relatively easy. It's relatively easy because I take the inverse function, que es this. Look. And the inverse function is cubic root. X minus. Oh, I know. The cubic root, the domain of the cubic root, I know it's already a number. Okay, remember, the only guy that have restriction is a square root. But when the index of the root is odd number, no. It's already a number. Look like we are or no? Okay, look, let me see. Let me explain. You know very well this fact. A square root, negative 25, FII. Wow, why, professor? Because the square root, so the negative quantity inside the square root is imaginary. And imaginary is completely out the real number. Okay? However, cubic root, negative 27 and negative 3. It's real. It's real. Why? Because the idea behind cubic root is find one number, multiply by itself 3 times, give me the number inside the radical, que is minus 27. It's real, everything is real. And this situation happens when the index is 5 or is 7, or is odd number. But si it's even number, like a 2, like a 4, like a 6, we have problem with the imaginary, because the only possibility phi times phi is 25, I squared, y I know que I squared negative 1, entonces negative 25. And finally we get that, pero you get when the answer is imaginary. Okay, entonces, in conclusion, the domain of the cubic something is a real number, and it's equivalent to the range of the original function. Okay, super. I promise you today we are doing 3 examples of this. 3 examples. I bring. In the review packet, we see more. But so far, okay. What is the last step, Professor? You say get 5 steps. Okay. 5 steps. Sorry, this is called algebra. Too many steps, I don't care. Step 5. Step 5, I try to do my best. In order to make a graph of the original function, actually I did before, and the inverse function. And this is specific example. And let's see what happens when you see together this. It's easy. Let me try to show you. Okay, too many information in this page. I can erase the board or no? No erase. Okay, let's bring the rectangular coordinate system after you see, and that's more clear. What's my goal now? My goal now is to do the graph of both functions. Now, actually, the first function is f of x equal x cubed plus 3. I did. Is 3. Supposing 1 is 4, no? Because 1 cubed is 4. y en -1. This is clásica. You evaluate en 0, you evaluate en 1, and you evaluate en -1. Entonces, when you evaluate en 0, the y value is 3. When you evaluate in 1, the y value is 4, no? Because the 1 cubed is 1, plus 3 is 4. And when you evaluate in -1, -1 cubed is -1, entonces y is 2. Okay, super. Entonces we have 0, 3,0, 1,4, -1,2. Boom. Something like that. My graph look like that, approximately. Okay, this is the graph of the y equal x cubed plus 1, plus 3, sorry. This arrow indicates us to continue forever in that direction, approximately. You know. Entonces, what is the idea behind the inversive function? Well, the inversive function, look, suppose that you are doing the graph of the inversive function, que es cubic root x minus 3. Wow, it's easy, not necessarily plugging in. Because the thing that we are doing, remember, is interchange x and y. Therefore, the classical point is 0,3, 1,4, and -1,2, and the original would be and the inverse 3,0, 4,1, and 2,-1. Do you see that? According to this idea, you interchange x and y. No, okay, I plot that. 3,0, 3,0 here. Boom. 4,1 is here. Boom. And 2,-1 here. Boom. Our graph look like that. Approximately, you know. This is the graph of the inversive function, that is inversive function is cubic root x minus. Do you think it's super easy? I have more in the graphic part. Both graphs are symmetric with respect the line y equals x. And what is this line? Well, this line is the line can be set here. We set the first quadrant and the third quadrant. Wow. Well, okay. I don't like this. I draw similar to the asymptote. Actually, it's not asymptote. There's an axial symmetry. Okay, this and it's that. This line is the line y equals. Do you see that? Any question? Do you see or no? Entonces es super easy to do the graph of the inverse because when you are doing the graph of the original, the only thing you should do is interchange x and y, and you get the graph of the inverse. And by the way, it's symmetric with respect to the line y equals x. Okay, I want to show you in detail in Desmos. Let me try to bring Desmos. Let me try to share Desmos. Boom. Switching. Desmos. Do you see Desmos? Do you see or no? Good. Example 1, look. What is that? Look, this example is, look. The original function. X cubed plus 3. The inverse function is square root, cubic root, sorry. And Desmos have no cubic root. I raised to the 1/3 is equivalent, no? This is the cubic, this is the inverse, and this is the line is symmetric. And the classical point I'm using was, remember, 0,3. The analog point is 3,0. Look, it's symmetric. 1,4, 4,1, -1,2, 2,-1. Bam! End the story. Easy or no? Easy or no? Complicated? Or easy? Huh? Do you see? Question? Come on, opinion. Professor, this chapter is hard. I know it's hard. Very hard. Okay. Let me go again to the whiteboard. This is whiteboard. Let's do it in one. Not complicated, but no easy. Okay. Yeah. And this is just the beginning, guys. After the review, you see more clear everything, no? Okay, so I want to take advantage and erase everything in the board. Let's move on to example 2. Okay, I suppose I want to do faster because it's easier. Example 2. Example 2. You see the whiteboard, no? Or no? Guy, you see whiteboard? Answer me. Yes, good. Okay, suppose this. Suppose f of x is equal x squared. So I put semicolon here, x greater than or equal to 0. This is the information that's given. So the problem say this function is given. Please do everything. The analysis. Analysis determines if 1 to 1 or no. Number 2, determine the equation for inversion. Number 3, checking, double checking the composition. Number 3, determine domain and range. And number 4, do the graph of both the original and inverse. Okay? So step 1. Step 1 is determine if 1 to 1 function or no. But you say, well, professor, I don't understand anything. What the hell is that? What the hell is that? What the hell is that? What is the reason they don't give me the function like that? And that's it. The reason is because we have the restrictions. So actually, I explained before, this is a quadratic function, but not totally parabola, sino half of parabola, like that. This is x, this is y, and when you apply the famous vertical line test, horizontal line test, sorry, touching only one point, therefore, yes, this is 1 to 1. It is 1 to 1. Function, therefore, it is invertible. Or in other words, the inverse function exists. Okay? See, we have the entire parabola, the horizontal line that fell. The answer is no. So si I omit that part, the answer is no. And we finish because it's not invertible. So the inverse function do not exist. And I cannot do anything, right? But no. It's obvious that no. It's obvious that our problem contains this restriction. It's not the full parabola, it's a half of parabola. Maybe the positive branch of the parabola or the negative branch. Doesn't matter. Everyone follow me with this idea or no? Yes or no? Good. Jonathan Solano, he said yes. Now, the second step is the most important, is find the equation for the inverse. Okay, good. Good home. You see? Be patient. Little by little, you understand. You only pay attention. That's it. Well, the equation for the inverse is you replace f of x or y. Always, anytime. You interchange x and y. Like that. So this is x, this is y. Just curious what is passing the horizontal line test, but no vertical. Okay, vertical line test is to prove si es a function or no. Horizontal is to prove que es 1 to 1. But actually, I suppose que es a function because, well, no, it's no curiosity, it's logical. Okay, in this case, pass the vertical. Okay, and this is logical que happen because it's a function. But pass also the horizontal to say 1. It's the thing that we're discussing today. Entonces this is the inverse. expressed and implicit. Wow, I don't like implicit. Never. I leave it like that. Implicit form. No good. So now you solve for y because I need the explicit. This is a classic. We see any example get the same. You solve for y, so you apply square root both sides. The y alone is equal to square root x. And I put plus or minus. What do you think? Plus or minus or no? Yes or no? When you apply square root, both sides. And the solution for the equation, always I put plus or minus. However, in this example, no plus or minus. Because remember, we have that restriction can include only the positive, guys. So no plus or minus. No plus or minus. Only plus default plus. Okay? And this new y represents the inverse function. And this is completely logical result. At the beginning, I explained that the inverse of the square is a square root. Okay? Clear so far? Super. Let's move on to number 3, get the checking, double checking. See, when you put together that function, like that, composition, or like that, actually endoss each other. I suppose that yes, using intuition. It's no big deal to understand. So the inverse is the square root. The square root inside this is like a square root, a square, something like that. So when you that function plug it in here, this square is outside, and square root endoss each other, and the answer is x. Okay, by the way, guys, this x is the identity function. What mean identity? This is one function where when you plug it in 10, the answer is 10. When you plug it in 3, the answer is 3. It's identity. And this is logic that can happen because you apply two functions and one function endoss another function. Endoss each other. In this direction, well, in this direction is f inside inversion. It's like inverse is this and a square inside. So this, you put this now inside this. Same thing. Identity. Checking. Check. It's okay. Yeah, it's okay. It's inversion function. Okay, super. The fourth step is determine domain and range. Domain and range of what? Of both. So step 4 is the analysis of domain and range. Step 4. 4, not 3, 4. I organize this like that. Domain of f. Who is f? F is x squared. No? Range of x squared. Domain of square root. Get inverse. This is the f. And range of square root. Well, let me start for domain of the region. How do you know that? Well, it's given. This information is given. Look, it's this semicolon. Okay, introduced here at the beginning with a restriction. This is the domain. It's obvious, right? If I do not introduce this restriction, the function is no one to one. Don't pass the horizontal lines. So this is the domain. How you write domain in interval notation? Bracket 0, comma infinity. Because it's only positive. All real number, but positive, no negative. The domain of the region is bracket 0, comma infinity. Okay, it's exactly the same of the range of this. And this is logical. Why is logical? Suppose in the test 2, I say you determine the domain of this. Well, to investigate something. Well, no, domain is this. Domain of this. Okay, sorry. This is a range. Okay, this and this is the same by definition. Boom. But I have no idea what's going on with the domain of this. Well, yes, I have idea. It's easy for me because in the test one, when you have square root, you take the expression inside and you put against this expression is non-negative. Because I know this negative is imaginary. This is equivalent to say exactly the same. This is equivalent in interval notation bracket 0, infinity. And this is exactly the same of the range of the x squared by definition. This is exactly the same. Entonces, professor, always the four guy is the same. No, not always. And the two examples we're doing today, yes, but not always happen in this situation. And what about the step 5? Get the graphic part. Well, the graphic part, well, let me try to do my best after we see this. Okay, let me bring, the image of the rectangular coordinate system. Boom. Exactly. Let's do in the graph of the function f of x equal x squared, semicolon, x greater than or equal to 0. Well, it's a parabola, but half of parabola. One famous point is 0, 0. Another famous point, okay, look, x equals 0, y equals 0. X equal 1, y equal 1, because 1 square of 1, 1, 1. And negative 1, no. Negative 1, no, it's totally out the domain. No good. Because domain to be one-to-one function is restricted only for the positive value. Well, okay, but I take another, maybe 2. And 2 squared 4, y equal 4. Okay. And the point are 0, 0, 1, 1, nice, and 2, 4. Okay, I plot that. 2, 4 is here. Okay, I connected this, and this. This is my parabola. 3 is 9. Continue here, increasing too fast. This is the function x squared. Under the restriction is x is only positive or 0. And what about the inverse function? It's a square root. The inverse function is a square root. It's a square root. Well, it's easy. Not necessarily plugging in. It's the same value. You interchange x and y. By coincidence, 0, 0 is the same. 1, 1 is the same. But the third no, is 4, 2. So this is perfect coincidence. The 0, 0 is the same. 1, 1 is the same. The 4, 2 is here. So our graph looks like that. And this is the inverse function. Okay, it's a square root of x. And one more time happen. Okay, the graph is symmetric with the identity function, that the line can be set. The first quadrant, look, is y equal x. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. And that part, no, because we have no negative part. Okay. We did the graph. We did the best. Okay, I can by hand. Of course, I use in decimals. Let me try. Let me share the screen for decimals. Boom. Inverse function. Okay, do you see this one now? Oh no. Okay, this was the first example. Now let's do the second. You see no? Yes or no? Good. The second is, look, is a square root and a square function. I also have the classical line y equal x, the symmetric, and the point I used was the same, 0, 0, 1, 1, 2,4, and the inverse is 4, 2. Wow, amazing. And blue color, the original function, and orange color, the inverse function. Bam, piece of cake. Any question? Any question? So we have time to do one more, a little bit complicated example. A little bit complicated example. Let me try. Okay, one more time. I share the whiteboard. Switching to whiteboard. Boom. Boom. Whiteboard now. Do you see whiteboard? Good. Erase everything in example 2. Let's move on to example 3. Example 3 is a little bit more complicated. Let me try to do my best to explain that. Example 3. Well, example 3 is the function is 1 over x plus 1. Wow, it's like a reciprocal function, but we have some transformation. In that case, I suppose it's horizontal chief. Because it's inside the parentheses, no it's plus 1 outside. In this case, to the left. But okay, I don't care. Okay, entonces es, bueno, okay, I care. Okay, basically, you know very well what is the graph of this, approximately, no? Okay, and this is a rational function. I don't want to discuss in detail any possibility, horizontal asymptote, vertical asymptote, no. Okay, basically, we have one vertical asymptote, look, at x plus 1 equals 0, okay, negative. The negative 1 get here, negative 1, we have 1 vertical asymptote. And the horizontal asymptote, we have also, yes, because the degree of this is 0. It's a constant, and degree this is 1. You say, yes, we have a special case at y equals 0. Okay, so we have this. Suppose we are doing additional point. Okay, one interesting point is the y-intercept. Okay, it's at y equals 0. Entonces 1, because 0 plus 1 is 1, 1 divided by 1 is 1, 0,1 here. Entonces now I suppose hypothetically, this, I do a complete analysis. But okay, much better using decimals, and you see the curve look like that. Approximately. Entonces now, in the analysis of the inverse, remember in the step 1, I need to see CS 1-to-1 function on 1-to-1 function or no. What do you think? Yes or no? Yes or no? What is the test that we are using to verify case 1-to-1? What is the test? Yes. Clifford say yes. But Clifford, what is the test that you're using? What is the test that I am using? What is the test? The horizontal. Look, Bob. Very well. When you apply, whoop, crossing only 1 point, whoop, crossing only 1 point. Entonces, yes, it's invertible. By the way, yes, it's invertible. It's 1-to-1. Therefore, it's invertible. Entonces, my second step, well, I find the inverse equation. It's doing. Step 2 is find the inverse equation. So now you replace y for f of x. And we have x plus 1. This is the original. Now remember, you interchange x and y. This is the most important equation in this lecture. X is equal 1, y plus 1. This is implicit, not good. I need to do something in order to express it in explicit. Okay, entonces en explicit is, okay, in my opinion, in order to solve y, you apply cross multiplication like that, boom, 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 x times y plus 1 equal 1 times 1 is 1. And you apply y now distributive property xy plus x equal 1. Okay, now solve for y, xy is equal 1 minus x. I move x to the right hand side, negative, and divide by x. Y is equal 1 minus x divided by x. You can write like that if you want. Oh, you write like that. 1 over x minus x divided by x is 1. Either way, this way, I prefer that way, or this way. And this way, you can see that this look like similar to the reciprocal function, que es like that, except que es minus 1. So it's down, very good shift, 1 unit down. Pero this doesn't affect, bueno, the affect the horizontal, que es here. Pero doesn't affect the vertical. But it's okay, it's not important now. It's not important. Now, this is my new expression. So my function inverted, okay, the collection that we have so far is, the function that's given at the beginning is 1 over x plus 1. And the inverse function I discovered using algebra is 1 minus x over x. Boom. I finished the step 2 in this example. Okay. What is the next step? Well, the next step is verification. Verification, double checking, si un dos each other or no. O sea, you in the step 3, you verify F composition F inverse is equal identity, or inverse composition F is identity. Let's do it in this case a little bit complicated. Okay, what should I do? Well, okay. And this order, the inverse is this guy. I substitute it here, completed. Entonces we have 1 over, no x anymore, it's 1 minus x divided by x plus 1. Do you understand what are you doing? Do you understand what are you doing? Yes or no? Confusing? A little bit. Okay, composition. Composition is one function inside another function. We have that function, 1 over x plus 1. This is f. And the inverse is 1 minus x over x. See, I want to find the composition. You write like that. You write 1 over box plus 1. This box represents that part. And inside the box, you put 1 minus x divided by x. It's this guy. This guy completely inside this. More clear now? More clear now? More clear now? Good. Okay, let me erase everything in that part. Okay, now, let me manipulate this. Well. You find the least common denominator. Why not? This x at the bar. 1 minus x plus x. Welcome from this extra x. You divide the LCD divided by the denominator, multiplied by this x, divided by 1 is x, times 1 is x. And this x is cancelled. And we have 1 over x, reciprocal of the reciprocal is flipped. 1 is 1, time, flip it up, x over 1 is x. And this is the answer we expect, the identity. Wow, fantastic. Okay, let's do it in opposite direction. The opposite direction is, let me see, I have no idea. This is 1 over x plus 1, and this is 1 minus x over x. Basically is, you take that, and you replace this expression here and here. So double replace. Okay, is 1 minus box divided by another box. And inside the box, we have 1 over x plus 1 and 1 over x plus 1. Everyone follow me? We're doing the composition. The composition, the original inside the inverse function. Do you follow me or no? Totally lost? Confusing? The rest is elementary. Follow me. Okay. The rest is elementary. Look at that. Look at that. Look at that. You find the LCD. It obviously is x plus 1. Because it's the only expression we have in the denominator. This divided by this times 1 is x plus 1 minus 1. Boom. This 1 is this 1. And this 1 multiplied by the LCD, que is x plus 1 times 1 is x plus 1. And the bottom, well, you have 1 over x plus 1. Okay, what's going on? Well, okay, this is cancel. So stay here, x over x plus 1 divided by 1 over x plus 1. Okay. Okay, one shortcut is we can cancel out this and this. But no, the student don't understand very well this shortcut. Remember, it's division. It's a complex division. You copy the top exactly the same and flip at the bottom. This is cancel. And the top, we have x, and the bottom 1. It's the x again. Now, there's a confirmation that we are doing okay. That function is inverse of each other, and when you put together, undoes each other. Super cool, super cool, super clear. Okay. Go ahead. Question. Confusing, clear or no? Guy, this is it's confusing the algebra. No? Oh, clear. Okay, Jonathan. Solano, this is clear. This is 1033, guys. Algebra. Okay, now let's move on to domain. This is step 4. Step 4 is domain. Remember, we have domain of f. Let me simplification of that. A range of f, or range of f, sorry, here. And that order is much better. I don't know why, for me it's much better. Domain of the inverse and range of the inverse. Okay, what is the domain of the original? Wow, look at that. This is the original. This is the original. This is the original. And I discover when I try to do the graph, okay, we have a vertical asymptote at -1. Okay, so now my domain is all real number. Okay, look. All real number. Let me use in that notation. If you want, you can use in interval notation. But I like using this notation now here. S except the bad guy is -1. Do you understand why? Because -1, and so you plug in -1 here. Look at that. F at -1 is 1 over -1 plus 1, and -1 plus 1 is 0, and division by 0 undefined. Completely undefined. No good. -1 is a bad guy. It's a restriction. It's all real number except -1. Exactly. Because in -1 we have vertical asymptote until to be undefined. And that is equivalent to the range of the inverse. But in the range of the inverse, you put y such that y no -1. Because the range is associated with the y value and the inverse. And the domain is associated with the x value and the original. Okay, I understand this very well. And the inverse. Well, the inverse I use in that function. And that function is clear, at least for me, that the only restriction we have at division is x not 0. because it's 0 in the denominator undefined again. So the domain of the inverse is x such that x not 0. You see, it always is the same, dependent. And the range is equivalent to the domain of the is y such that y not 0. Boom, final answer. Final answer, final answer. Okay, so now let's do in the graph. The graph is very complicated by hand. That is a reason I bring in decimals to illustrate. You see a new situation is important to understand. Look, decimals now. Let me share the screen to decimals. Okay, I promise, guys, this is the last part for today. Okay. Okay, there you go. Do you see decimals? Okay, no example. Good, good. No example 2, example 3 now. Wow, what the hell is that? Okay, let me analyze step by step. Look. Okay, let me delete that, delete, no, this, and this. Okay, this is the rational function. Remember the rational function have vertical asymptote here, boom, and -1, and horizontal asymptote and 0. Boom, this is the rational. Okay, now the inverse function is this. Asymmetric with respect to the line y equals x. Look at that. Boom. Do you see it's perfect symmetric? Let me omit temporarily the asymptote. Bam, bam. And you focus it in the red graph and the purple color graph. Completely the red one is symmetric with respect to that. Now the line y equals x behave like a mirror. Entonces now suppose que the red is the image of the purple, or the purple is the image of the red. Okay, yeah, I restore the asymptote. Vertical, horizontal. And amazing, notice, this is the most important idea I want to explain today. Okay, let me delete mentally to don't interfere with the idea I want to discover. Que the asymptote for the is y equal -1. Oh, okay, and x equals 0. X equals 0. Okay. It's important. Notice. The original function have two asymptotes. This is the vertical for the original, and this is the horizontal for the original. And the new function, the inverse function, sorry, no new, the inverse function, have also two asymptotes, a y equal -1 and x equals 0. Entonces, notice que es a coincidence, the same value. Okay, and the original x is equal to -1, and the inverse is y equal to -1. And the original is y equals 0, and the inverse is x equals 0. So the value is the same, but change the behavior. One horizontal and the original is vertical in the inverse. And one vertical and the original is horizontal and the vertical. The same value, but change the behavior. Change horizontal, and this is classic for any function that we study. So basically, this chapter is centered in the two special functions, que is the exponential function and the logarithmic function. And by the way, that function are inverse function each other. And when you study the property for the exponential have asymptote, and the logarithm have the same asymptote and the same value, but vertical. The horizontal become vertical in the logarithmic, and the vertical in the logarithm become horizontal in the exponential. This is important thing now. Okay, guys, everything is gone. Time is over. We continue. Remember, today, send me by email the test on paper. Let me start recording.